Hello friends, welcome. So let's find the derivative of x squared plus y equals 1 using two different methods. And these two different methods will kind of show the reason why implicit differentiation is important. So let's use the general method for finding derivative. And to use that method, we have to first of all make y the subject of the formula. So what we can do is just take x squared to the other side, subtract x squared from both sides, and you have y is equal to 1 minus x squared. So dy dx is just going to be, you find the derivative of 1. 1 is a constant. The derivative of a constant is 0 minus the derivative of x squared using the power rule is just 2x. So dy dx is just going to be what? Negative 2x. So this is a general method that is known, right? Now let's use the implicit, using the method of implicit differentiation. So using the method of implicit differentiation, I will take d dx of each term, right? So I have d dx of y and then d dx of 1, right? So since both variable are the same in the first term, right? In this term, the variable with which we want to take the derivative is x, and this x squared, the variable here is x, right? So I can easily just take the derivative, and I will just have 2x, right? Plus, now if you look at this, right, the variable with which we want to take the derivative is x, and then the variable here is y. So what I can do in order to match the variable, what I can do is that I can write the d dy of y dy dx. So I'm going to explain this. Now this and this, they're exactly the same thing. How? Okay, let's just say, if let's just do this, right? Let's just do this. Let's say if I divide this dy and I divide this dy, what am I left with? I'm going to be left with I'm going to be left with d dy of what? Of dx, which is exactly what I have here, right? So they're actually exactly the same thing. And once again, the reason why I'm doing this, like what I have here, the reason why I'm doing that is that I want the variables, this variable here and this variable here to match so that I can easily take the derivative. Do you understand? So now I'm just going to erase all this. So and then we move forward from here. So this is just going to be um this is just going to be the derivative of 1 is 0, right? Of a constant is 0. So I have 2x plus so I have this is just 1, right? Dot dy dx equals 0, and this is just going to be dy dx. If you subtract 2x from both sides, it's just going to be negative 2x. Okay, so now this method 2, appears to be more intensive, but let's look at another example to see where method 2 might be more um, you know, preferable, or might be more helpful when finding derivatives. So let's look at this example, right? So for this example, if I want to use the first method, right, that means um, I have to make y the subject of the formula. So I'm just quickly going to make y the subject of the formula. So this is just going to be y will just be 2 minus x um, divided by 3, and this is just going to be the fourth root. So now imagine I need to take the derivative of this, right? So if I want to take derivative of this using the normal method, that means I have to do a couple of things. I have to use the chain rule. I have to most likely use the maybe the quotient rule. Like you have to use all those rules. But with the implicit differentiation, all I have to do, so I will just write using um, implicit differentiation, right? Using implicit differentiation, all I have to do is to just you know just say d dx of the first name, which is x, plus d dx of the second term, which is 3y to the power of 4, then equals d dx of 2, right? D dx of x, since both variables are the same, this x and this x, since both variables are the same, I just have this is just going to be um, this is just going to be 1, right? Plus d dx of 3y to the power of 4. You might not be able to take the derivative that way because the variable here is x and the variable here is y. They don't match. So I have to make the variable match. So this is just going to be d dy of 3y to the power of 4 dy dx, right? And once again, this and this, they're exactly the same, right? They're exactly the same because if I divide the dy and dx, I'm back there. I mean, if I divide the dy in the denominator here and the dy here, I'm back to what I have. So, so they are kind of exactly the same. So the derivative of a constant here is just 0, right? So I will have 1 plus d dy of 3y to the power of 4 is just going to be, using the power rule, is just going to be 12y to the power of 3. Then I have my dy dx equals 0. And this is just going to be, if I subtract 1 from both sides, I have, I have dy dx is going to be -1. Then I will divide by 12y cubed, provided that given that y is not equal to 0, right? So my dy dx is just going to be, yeah, it's just going to be that, exactly this, what I have to rewrite it. Yeah. So look at, with implicit differentiation, just like at 1, 2, 3, 4, like 4 lines, and you're done. But if you want to use the normal method, you might have to do a couple of steps. Do you understand? You have to do the chain rule and and all that. So this is where the implicit method, is really helpful, and that's why it's good you understand implicit differentiation. I hope this video helps you. Um, Please subscribe so that you can get more notification. You can be the first to get notified when I post more helpful content. Thank you.